Okay, here is a lesson on 1.1.4 inequalities. If you want to pause the computer screen really quickly and you could get down the definitions for inequalities and rules for inequalities. I'm just going to go through these really quickly. An inequality is an algebraic statement that shows a group of values with the same, less than, or greater than relationship. Note that inequalities have a group of solutions and equations have one solution. Alright, that's going to be kind of a common theme that we'll talk about more in the lesson. Rules for inequalities. If we multiply or divide by a negative, we must switch the less than sign to the opposite. So if it's less than, it becomes greater than. If it was greater than, then it has to switch to less than. So you have to change the direction of the sign. Alright, let's just do some examples here and work through just some different scenarios. We want to treat inequalities as much like an equation as we possibly can, but the solution sets will be different, and we'll talk about how that looks. So again, even though you see this inequality symbol here, greater than, we want to treat that as if it's an equal sign, and we want to keep both sides balanced. So I'm going to subtract 5 from both sides of the inequality, and I get x is greater than negative 8. So that means every single number that's bigger than negative 8 is a solution to this inequality that we just had. Well, that's way more numbers than just negative 7 or 12 or 3 million. It's every single number that's bigger than negative 8. So we can't just list every single one of those out. That would take forever. So we use a number line. And so we just use kind of a strategic location on the number line and mark negative 8. And I'm going to circle it. I circle it more as a guide. It's not included in my solution. It means everything coming up to this point, so I don't want to include it. But then what I do is I shade on the number line everywhere to the right, because that's where the numbers get bigger, and that represents every number bigger than negative 8. All right, number 2, we have variables on both sides of the inequality, so we want to try to isolate the variables and isolate the constants. So there on the right side there's more x's, so I'm going to subtract 2x from both sides. And now I have 6 is less than or equal to 3x minus 3. Add 3 to both sides to isolate the variable. 9 is less than or equal to 3x. And in order to get x by itself, I need to divide both sides by 3. Now since 3 is positive, I don't need to worry about changing the sign. And that's going to leave me with 3 is less than or equal to x. Now some people are okay with it, with their answer looking like this. Others would prefer to have the variable on the left side. If you do that, you're going to need to bring the symbol with it. So that will be x is greater than or equal to 3. Notice the alligator mouth, it was biting the x to begin with, so it should still be biting the x when I swap the sides. Alright, so that says x is greater than or equal to 3. So we mark the 3 strategically on our number line, and this time 3 is going to be included in our solution, so it'll be a closed circle because again, greater than or equal to 3. Greater than's to the right, so we shade everywhere to the right, and every number 3 or bigger is the solution. Alright, number 3. Got a fraction in here, so I want to get rid of the denominator, so I'll go ahead and do the inverse operation of division, which would be multiplication. So these two cancel out, and I'm left with 2x plus 3 is less than 14. Now I'm going to subtract 3 from both sides in an effort to isolate the variable. 2x is less than 11. Divide everything by 2. Again, dividing by a positive number, so I don't have to switch the sign. X is less than, you could leave it as 11 over 2, or you could write a decimal 5.5. 5.5 goes on my number line, and since this is less than, I would do an open circle and then shade to the left. Less than, all the numbers that are smaller than 5.5 are to the left. Again, open circle because it's less than, not less than or equal to. Alright, number 4. Variables on both sides, but I have some distribution I need to pay attention to, so let's go ahead and deal with that. So I'm going to go ahead and keep the 3x minus 2 unchanged, but then I'm going to go ahead and distribute a negative 2, so negative 2x minus 4. Before I start moving anything around, I want to combine like terms to try to simplify. So 3x minus 2 is greater than or equal to, and then 4 and a negative 4 is 0. So then I'm just left with negative 2x. Well, this is where you have a little bit of kind of some gray area where normally I would like to send all the x's to the left side because there's more x's on the left. If I did that, it would not leave anything on the right side of the inequality, and that makes some people nervous. So I'm just going to go ahead and subtract 3x from both sides. Now, subtracting does not make us have to change the sign, even though it's negative. That's only multiplication and division. All right, so these cancel out. Negative 2 is greater than or equal to negative 5x. And now I'm being really cautious. I go ahead and divide by negative 5 in order to isolate the variable. And I divided by negative 5, so that means change the sign. So that's going to leave me with a positive 2/5 less than or equal to x, because those canceled out. So now, if I don't like how that looks, I can swap it around. Remember, x would be greater than or equal to 2/5 here. So I've got my 2/5. You can turn this into 0.4 if you'd like. This is going to be a closed circle since it's greater than or equal to, and then we'll shade to the right. All right, final example, number 5. Okay, got to be very cautious about distributing the negative 5 here, but I don't have to worry about changing the sign just yet because I'm not affecting both sides of the inequality. Negative 5 times u is negative 5u. Negative 5 times negative 19. A lot of you might need to pick up the calculator, not doing that mentally, but that's going to be 95 is less than or equal to negative 6 plus 2u. Now I am going to go ahead and add 5u to both sides to try to keep my u's positive. 95 is less than or equal to negative 6 plus 7u. Alright, and then I'm going to add 6 to try to isolate the variable. So I've got 101 is less than or equal to 7u. And then finally divide everything by 7. And I know what you're thinking again, well, that's definitely going to be decimals. That's okay. I'm going to leave it as a fraction though. 101 divided by 7. And I don't really like the way that looks, so u is greater than or equal to 101 over 7. That way I'm real clear on which way to shade. Alright, so I've got my 101 over 7. So 101 over 7. And I'm going to have a closed circle since it's greater than or equal to, and I shade to the right.